Welcome to another mole concept tutorial, okay? Where we have talked about the mole, relative atomic mass, relative molecular mass, empirical formula, molecular formula, and we even spoke about some gas law, okay? Now today we're going to see how this relates to the mole more in details by determining the relative molecular mass using the ideal gas equation. And remember the ideal gas equation, we introduce M, which is stand for the mole. And we all know that we can calculate the mole by a certain formula which is given mass divided by molar mass. And from there, but first to begin with, let me write down the ideal gas equation. And before we get started, if you're new to this channel and if you've enjoyed my videos for now, please consider subscribing, give me a thumbs up, and turn on the notification bell so that you will not miss any of my tutorial. And hope you're going to enjoy learning with me. Okay, so to begin with, like I said, let me write down the ideal gas equation, which is EV is equals to N arrow T. Okay, now you and I both know that this N, which is the mole, it is given mass divided by molar mass. So we are going to have PV equals to all these times arrow T. Okay, so from here, making molar mass which is same as relative molecular mass is something called the formula, we end up obtaining something of this nature. So divided by PV. Now, you gotta know something, that you have a dealing with gas, and sometimes the temperature will change, and since we're dealing with gas, which the molecules are not held by strong intermolecular forces, when the temperature change, the volume change. And you know that when volume change, especially mass is going to change when we're talking about gases. So we can have this also be written like this: given mass, and this given mass can vary. Okay, this given mass can vary. M2 minus M1 divided by P into V2 minus V1 times RT. Moreover, we can still use this relationship we derive last time from the ideal gas equation, which is this relationship EV on T is equal to E1 V1 on T. Now, how can we use this particular relation in deriving the relative molecular mass? In case we actually calculate the volume of a certain gas with certain condition, and we know about this formula of calculation in mole, N, which is equal to given volume divided by molar volume. And we clearly know here that when we're working on that standard temperature and pressure, the volume is 22,400 cm3, which is 22.4 dm3. So here we can clearly realize that we already know the volume. We already know the molar volume. So if we have the volume, the given volume from here, we can simply calculate the mole here. And in case we had mole already, we can also calculate the molar volume, from which we can relate and calculate the molar mass. So less of speech, more of action. Let's take an example and solve. So this is the example here on the board, which says 0.18 gram of a liquid gave rise to 60 cm3 of vapor at 98 degrees centigrade and 0.987 atmosphere. Calculate the relative molecular mass. Now, let's say this was the initial condition, and the final condition is at STP. So we're going to have something of this nature. We name this. Well, you can name this one here, whatever you want. It can be 1, 2, it can be 0, but it must be different from the one on the other side of the equation. This one method. Okay. So So you know the temperature in Kelvin is 273. You know the pressure, 1 atmosphere. So we're looking for the volume. So this implies that V2 is going to be equal to P1 V1 T2 divided by P2 T1. So substituting the values, P2 is equal to P1. Initial pressure is 0.987. 0.987 times the volume of 60 cm3 times the temperature, calculating Kelvin, 273 plus 98 equals to 371. Second pressure 1 times. Sorry. Instead, this 371 is supposed to be down. And 273 up. This other for the mistake. So doing our maths, all this is equal to 43.6 cm3. Now, we work in this condition in STP. I will know how to calculate the mole when the condition is at STP, which is given mole volume is divided by molar volume, that's the volume at STP. I also know about the other formula calculating the mole, which is given mass divided by molar mass. Now, these two formulas will give the same result. So since they give the same result, I want to code the two formulas. I look for the unknown. So what I mean is that the given volume divided by molar volume equals to given mass divided by molar mass. And this is the unknown here, molar mass. So if we make molar mass equal to the formula, we end up having molar mass equals to given mass times molar volume divided by given volume. So molar mass is equals to, what was given mass? 0.18. You can put a 0 if you like, and molar volume into 2,400 cm3 divided by the given volume, which is this, 3.6. $92.477. I would like to put this in one decimal place, but I don't mention you. The cushion as also just an example. So you have 92.5 gram per mole. Now we're going to use the other methods. Okay. We're going to use the other method. Keeping in mind, just write this method, just write this value somewhere else. We use the method and you check out the answers are exactly the same. So we are going to use another method to solve this example. That is the formula which is from the ideal gas equation. So molar mass is equals to given mass times R times T divided by E. And please note that the volume here should be in cm cube. So you divide this cm cube by 1,000 to obtain the value in cm cube. So now from here, substituting the values. Given mass 0.18 times 0.08205 times 371 divided by the pressure 0.987 times 0.06. If I'm not mistaken, 60 divided by 10 divided by 100 and divided by 1,000. So we have this value, and if you punch in the calculator, you get 92.5 after rounding up to 1 decimal place. Okay, guys, that's all. Sorry, I just took one example, but if you have any problems so far with whatever thing I've solved, Just let me know, comment down below. And if you have any video suggestion on any advice or any tip on how to study, let me know in the comment down below. Our next tutorial, we're going to talk about concentration and standard solution. And then we're going to see another method of calculating the mole. But this part of chemistry of mole concept we're entering into is the most important, most vital. We are going to use all what we have learned here in order to derive, in order to find the concentration of different solution. Okay guys, see you in the next video. And please don't forget to subscribe, like and share with your friends. See you next time.